Hey everyone, this is the 6th lesson in the trigonometric functions unit. So we're looking today, kind of the opposite of what we did in this last lesson. We're going to go from the graph and now come up with our trig equations. So we're either going to come up with our sine equation or our cosine equation. And we can do both based on any single graph. Our first step in these equations is we want to find our C coefficient. We're going to look for our minimum and our maximum values. And average them to find the equation of the axis. And the equation of the axis, that always has y equals whatever value. That value is always C. So for this particular example that we have drawn here, our minimum value is 1. Our maximum is 5. So our equation of our axis we're going to take the average of these two things. So y is going to be 1 plus 5 over 2. 1 plus 5 is 6, divided by 2 is 3. So our axis is y equals 3. So C equals 3. Second step, we're going to find D. And in order to find D, we're going to find the period, how long it takes to complete one cycle. And remember, we talked about this not yesterday, in lesson number 5, 2 pi divided by our period is going to equal D. So our period here, if we start at 0, it takes us all the way to pi to complete one cycle. So our period is going to be pi. So that means D is 2 pi over the period, 2 pi over pi, which is just 2. So D equals 2. Step 3. Find A, our vertical stretch. And to do that, we're going to find the amplitude, which you can do just by looking, or it's your maximum minus your equation of the axis, or your C value. So our maximum value is 5. Our axis was at 3. Distance from our max to our equation of the axis is 2. Similarly, distance from the equation of the axis to the minimum is also 2. Step 4, we need to figure out, are we talking about determine if we are looking for a sine or a cosine function? We're going to do both in this example. So a sine function always starts at the axis of symmetry. It goes up and finishes off at the axis of symmetry again on its way up. So this cycle shows a sine function, whereas a cosine function starts at the peak and ends at the peak. So we would want to look at this function. We want to find one cycle that shows what we're looking for, either a sine or a cosine function. Step 5, we need to know what phase shift we have, if any. Phase shift. So, in this case, because we're doing both, a sine and a cosine, we need to look at both. Our sine function should start here, but it's been shifted over pi over 2 units. So it's pi over 2 to the right. Our cosine has been shifted 3 pi over 4 to the right. So from all this, we can write our equations. So as a sine function, or as a cosine function, either one, we had an a value of 2. We had a d value of 2. Other than the difference in what the actual function is, sine and cosine, this is the only change we had. Our phase shift in our sine function was pi over 2 to the right, so we're going to subtract pi over 2. For our cosine, it was 3 pi over 4 to the right, so we're going to subtract 3 pi over 4. And both these functions had an axis of symmetry at y equals 3. So our c was 3, so we need to add 3. We have a vertical shift up by 3. And there we go. We have two different functions for the same graph. We have a sine and we have a cosine function. This will differ slightly from what is shown on the completed lesson. So there's there's 3 different examples on there. I guess 2. This is the same as the one other that was on the sheet, but now you have 4 different examples for this same function. So you feel free. These 2 are not using reflections. The 2 on the completed lesson both have reflections. So take a look at all of them and make sure you're feeling comfortable with them. But we'll move on now to some more graphs. So for our first example, I've tried to draw as best I could the graph that's shown on the lesson. So our first step was finding our c value. So we need our maximum, which in this case, our maximum is 5, and our minimum is -1. So we're going to add those together. So 5 plus -1 over 2. 5 minus 1 is 4, divided by 2 is 2. So C equals 2. Finding our D value, we need to find the period. So you can either look max to max, min to min. They're kind of in between, so it might be easier actually to go from our points on our equation of the axis that goes right through y equals 2. So here we're going down at pi over 3. We go down, come up, come back down. This is 4 pi over 3. So from here to here is pi. D is 2 pi over the period. So if our period pi, 2 pi over pi, gives us 2. So we get a D value of 2. We want to find our amplitude. So our maximum is 5. Equation of the axis is 2. 5 minus 2 is 3. Our amplitude, or our A value, is 3. We're going to write this as both a sine and a cosine. So cosine, let's start here just to do a slightly different one than the one that's in the completed lesson. So we can do a cosine function, that's 1 cycle, or a sine function. Here's 1 cycle from here to here. So for the cosine function, we're shifting. Let's see, we're just past pi. Each box is pi over 6. So this would be pi, this is 7 pi over 6. Right in between those is going to be 13 pi over 12. We shift 13 pi over 12 to the right. So our h value is 13 pi over 12. For cosine, or for our sine function, 2 pi over 3 pi, this is going to be 5 pi over 6 to the right for our sine function. And now we can put those all together. So our A value is 3. We'll do both sine and cosine. D for both is 2. Now sine, our h was 5 pi over 6. So we subtract our h, we subtract 5 pi over 6. We subtract our h for our cosine, which is 13 pi over 12. Then we add our c, add our equation of the axis, add 2. And there we have a sine and a cosine equation that both represent this function here. 2 more examples are on that completed lesson, so feel free to look at that. Because really there's an unlimited amount depending on where you start your cycle. If you start one full cycle to the right, it's still going to be the same function. So there's an unlimited amount of sine and cosine function that you can write for all of these. So here's 2 examples. There's 2 more on the sheet, and I'll draw out this next example now. So here's our next example here. So we're going to do the exact same thing. We're going to find our c value to start. So we have a maximum. In this case, our maximum is at 700. our minimum value is 100. So C is going to equal the average of those. So we can add them and divide by 2. 800 over 2 is 400. So C equals 400 in this case. D, our period, our minimum we have at 0, we have another minimum at 80. So our period is 80. D is 2 pi over 80, 2 pi over the period, which is pi over 40. So it's okay, not every sine and cosine function using radians is going to have pi in our x-axis. That's okay, we can still, we just end up with a d value that has pi in it. So our d value is going to be pi over 40. Our amplitude, how much higher than our C value, 400, do we get? 400 to 700. That's an amplitude of 300. And a phase shift, we can either look at, let's say, a sine function starting here. So that would be a shift of 20 to the right. Oh, this is not a D, this is an H. I'm realizing maybe I cut some of this off. So an H value of 20 could be used for sine. We could also use 100. We could also use 60 and use a vertical reflection. Lots of different options. Or for cosine, we can either start here and use a vertical reflection, or we can start up here and say that we had a phase shift of 40 to the right. When we put together our equations, so our sine equation, we had an amplitude of 300, a d value of pi over 40, which is factored out of this interior term, x minus 20 plus 400, or for cosine, looks very similar, just with a different phase shift and cosine instead of sine. And we could use this function as well to show that graph. So multiple different options. Again, there's some more options on your sheet, but these are the two that I've chosen to talk through. So we got one more to look at, so I'll just take a second to draw this out, and then we can go over that as well. So to start off, our C value, that's the average of our maximum or minimum. So we have a maximum of 3, a minimum of -5. The average of those, 3 minus 5 is -2, over 2 is -1. D, we need to know about the period. So our period from low point to low point is 40, 2 pi over 40, same as pi over 20. Our amplitude, how much above -1 do we go? Well, we go all the way up to 3. So 3 minus -1, or 3 plus 1, is 4. And finally, our phase shifts. So our H values. For cosine, we can pick 20. Our maximum value, again, we could do no phase shift and just have a vertical reflection. That is for cosine. For sine, maybe we can do We need to be at our axis of symmetry going up, so we could pick 90. Again, that can change. There's lots of different options. We put this all together. We have our amplitude of 4. We have a d value of pi over 20. For sine, we had a phase shift of positive 90. So we get x minus 90 or x minus 20 for cosine. And our c value is -1, so we subtract 1 from both. And we're missing a square bracket. And that's our final example of these coming up with equations from the graphs. So if you have any questions on this material, again, let me know. But other than that, have a good day and goodbye.